Hi everyone. You've probably seen cool 3D maps like these. These scenes are not only interesting to look at, they can serve an important map function by showing the context of a topic in a way that a flat map cannot. This is especially true for topics like battles or other historical subjects where the terrain played an important role. In this video, I'll show you how to create 3D scenes like this using real-world terrains and some amazing, now-free software called View. What is View? View is a program for creating 3D scenes. Like other 3D software, View can create movie-quality scenes and animations. What makes View different is that it was created specifically for creating environments, such as terrain, land and sea scenes, and imaginary worlds. Since it was discontinued in 2024, it's now available for free, which is great news for map makers. View can create scenes so realistic that you'd swear they were photographs. Here are a few examples. View can do a lot of the same things other 3D software can do, such as creating shapes and things like spaceships. It can also import characters and other 3D objects, but its real strength is creating terrain. Although you can create 3D maps in QGIS, they don't begin to compare to what you can do in View. Why it's great for maps. What makes View so useful for map makers is its ability to import terrain files, such as a DEM. It also has a built-in world map that connects to several elevation databases, including USGS and Sentinel data. This makes it easy to take a normal terrain file and transform it into 3 dimensions. This technique is especially useful for battlefield maps that need to show the overall contours of an area or any subject that would benefit from a bird's eye view. View lets you depict terrain from ground level up to a high altitude, giving you a wide range of possibilities. It also has a large library of plants which you can paint onto the terrain to create the effect you want. If that weren't enough, you can animate a scene in View to simulate flying over a battlefield, for example. View is a very capable program and can do a lot more than creating realistic real-world terrain. Many people use it to create imaginary or fantasy worlds, such as these. Scenes like these use all of View's capabilities and are very complex to create. For creating real-world terrains, I'm going to focus on the tools and techniques necessary for that purpose, terrain, atmosphere, and lighting, and skip everything else. Getting started. If you've ever worked with any other 3D software, the View interface will look familiar. Because there are 3 axes to work with, View, like other 3D software, uses an interface with separate views for each axis: top, front, and side view. There's also a 4th view to show what the camera sees. The 3 main views show the scene from those perspectives and allow you to move or manipulate the scene in that dimension. The camera view shows the result of these actions on the overall scene you're creating. The left side of the screen shows a row of icons for creating different types of objects, such as terrain, water, basic shapes, and plants. The top of the screen has icons for things like open, save, zoom, and undo. The right side of the screen shows several panels. At the top are the object panels. These show properties of the selected object. Below this is the active camera window. This shows a small preview of the scene. At the bottom is the world browser. This shows all of the objects in the scene and functions a lot like the layers panel in QGIS. Before we import a real-world DEM, we'll create a simple terrain and use it to get familiar with how View works. Launch View. You'll see the startup screen. Click on the X to close this window. You'll see a blank window. Go to File, New. This window will appear. Make sure Physical is selected in the left column, then click on the upper left image, Default Atmosphere. The main interface will appear. On the left side, click on the terrain icon. The tooltip should say Height Field Terrain. A terrain square will appear. It will be red, indicating that it's selected. You'll see the terrain in all 4 view windows: top, front, side, and active camera. Click in any gray area or press the Escape key to deselect. Click in the top view window to activate it, then zoom out using the mouse wheel until you can see the entire terrain. Hold down the right mouse button to move any of the three main views without moving the terrain or other objects. Click on the Active Camera View window to make it active. Hold down the Alt or Option key and use the left mouse button to tilt the view by dragging the mouse down until the top of the terrain is showing. This takes a bit of practice. You'll probably need to zoom out. By default, the active camera view is often underneath the terrain. We'll be spending a lot of time in the active camera view. Zoom out of any view using the mouse scrolling wheel, or use the Move Camera Back and Forth and Pan camera controls in the Camera Control panel to change the active camera view. Before we can manipulate or move an object, we need to select it by clicking on it. Alternatively, you can click on the object in the browser panel to select it. First, I want to make the terrain bigger. I'll click in the top view window to make it active, then click on the terrain to select it. Selecting an object creates a bounding box around it. There are 8 control points on each box. These work like most graphic programs. Dragging a corner point scales the object proportionately. Dragging a center point on a side scales in one direction. You can rotate the object by moving the arrows just outside the corners of the bounding box. Next, I want the terrain to be higher. I'll click on the front view to make it active, zoom in, then click on the terrain to select it. A bounding box appears around it. To increase the height, I'll click on the control point in the center of the top of the bounding box and drag it upward. Now I'll click anywhere in a gray area to deselect, and I can see how my terrain has changed in the active camera view. You can use the top, front, and side views to change the width and height of the terrain this way. Gizmos. When you selected the terrain, you may have noticed some colored arrows. These are called gizmos, and they're an important part of View and other 3D programs. Gizmos let you move, rotate, and resize an object accurately along a single or multiple axes. Here's a gizmo. When you click on one of the main views, a gizmo will appear for that view. Here I've selected the top view. The gizmo in this view shows 2 arrows. These correspond to the X and Y axis. This makes sense, since the top view is a 2-dimensional view. I'll click on the arrow at the end of the Y axis, the green one, and move it up. Here's what that does. Note that the terrain moved up in the top view, like you'd expect, but the position of the terrain also changed in the side and active camera views. This makes sense if you think about it. Moving the terrain up in the top view moved it away from the camera. That's why it moved back in the side and active camera views. Now I'll move the terrain back to its original position, then I'll click on the X-axis arrow, the red one, and move it to the right. Here's what that does. Note that this time, the front view changed, but the side view stayed the same. This shows how the views interact with each other. Any movement in the top, front, or side views will cause a change in the active camera view. Besides moving objects, the gizmos also let you rotate and scale them. Each gizmo has some small boxes in 2 columns. These control specific functions. The left column controls the coordinate system and sets the origin point for altering the object. See the documentation for more about this. I usually ignore it. The right column has 3 buttons. From top to bottom, these are position, rotation, and scale. Clicking on one of these boxes changes the gizmo for that function. Position is the default setting for gizmos. Clicking on the rotation gizmo produces a circle. Moving the mouse along the circle will rotate the object in the dimension of that view. For many common functions such as moving, scaling, and rotating objects, View lets you use the bounding boxes or the gizmos. Either will produce the same result. I recommend spending a fair amount of time working with the gizmos and control points to get used to how the View interface works and how the different views interact with each other. See page 281 in the documentation for more about gizmos. In addition to moving the terrain or other objects, you can also move the camera. I've selected the main camera in the World browser. Here are the side and active camera views. The camera has its own gizmo, which I can use to move or rotate the camera. Here I've moved the camera away and rotated it. It's important to understand the relationship between manipulating the object and changing the camera position. If you use a gizmo to move or rotate an object, you haven't altered the object, you've changed its position in relation to the camera. Moving the terrain closer to the camera has exactly the same effect as moving the camera closer to the terrain. Using materials. Now that we have our basic terrain and know our way around the view interface, it's time to make our terrain look like something real. That's where materials come in. Materials give the object a skin. They make it look like it's made of or covered with some kind of material, such as stone, sand, or metal. Vue has a large library of material presets. You can customize these or create your own. We'll continue with the terrain we created earlier. To apply a material, select the terrain by clicking on it in the World browser or in any of the views. There are two ways to bring up the materials library. Right-click on the image in the Object Aspect window, or click the Load Material button. The Materials library will appear. The left column organizes materials into categories. Click on Landscapes if it's not already selected. These are the preset landscape materials. You can customize them or create your own. For now, click on the Rock and Grass one. You can see the result in the Camera Control window. To get a larger view, click on the Quick Render button in the Active Camera window. After a few seconds, you'll see this. That looks good, but it stops abruptly at the edge of the terrain. We'll fix this. First, click on the ground layer in the World browser to select it and apply the rock and grass material to it. That gives us this. That's better. Now I'll click the Quick Render button again. Here's how it looks now. That's much better. Atmospheres. Our scene needs one more thing: sky. Vue has a very powerful atmosphere system that lets you control every aspect of the sky, including clouds and weather. For this tutorial, we'll stick to simple skies. We'll continue with our scene. Go to Atmosphere, Load Atmosphere. This window will appear. These are preset skies. The left side shows the categories available. Click on some of the presets to try them. Click on Yes, Update My Camera, then click again on Yes, Update the Sun Position. You'll see the change in Camera Control panel. When you're done, go back to Load Atmosphere, then click on the Morning preset. Click on the Quick Render button in the Active Camera view. When it's done, you'll see this. And there's your scene with morning sun. Getting real-world terrain into Vue. Now that you're familiar with how Vue works, we can move on to the main subject. There are two ways to get real-world terrain into Vue. Using Vue's built-in world map. This is quick and easy, but the resolution can be a problem. Using a DEM file. This is a more involved process, but can produce better results. I'll demonstrate both of these methods in this video. Importing DEM files. Vue can import a DEM from all the usual sources. In this video, I'll use DEM files from the USGS and Open Topography websites. Your DEM should be in GeoTIFF format. If your file is in another format, it should work as long as it's a grayscale image. Vue will read the black as low and the white as high. The import steps differ depending on whether your DEM is a single file or tiles, such as from the USGS. Getting a single DEM into Vue is simple. I'll use Open Topography as an example. Download the file and unzip it if necessary. If you have a choice of format, choose GeoTIFF. Go to Vue and create a new document using the default atmosphere. Go to File, Import Object. Navigate to the saved DEM and open it. A dialog box will appear. Click OK. You might have the choice of importing the file as a procedural or height field terrain. Select Height field. It may take a minute to load, especially if it's a large or high-resolution file. Once it loads, We're ready to go. We'll cover tiled elevation files in the next step. Pearl Harbor Map. For our first real-world terrain, we'll create an image of Oahu, similar to the Pearl Harbor map shown earlier. I created that a long time ago using a program called Bryce. View is far more capable. For areas within the US, the national map offers DEM files at a greater resolution than other data sources. If the area you're selecting is small and you need a high level of detail, this is your best option. For larger areas, this data might have too much detail. In that case, use Open Topography 30-meter or 90-meter data. I'll go to the National Map website, zoom into Oahu, and check the box for elevation products. Clicking the Search Products button reveals 2 files. I'll download both files and load them into QGIS. Next, I'll run the merge operation, raster, miscellaneous, merge, to join the 2 files. I'll export this by right-clicking on the merged layer and selecting Export, Save As. In the Save As window, select Raw Data for the output mode and save it to your computer. That's it for QGIS. The DEM is now ready to import into View. Open View and create a new file by going to File, New, and clicking on the default atmosphere. You'll see the empty View interface. Go to File, Import Object, and find the DEM, then click Open. 2 boxes will appear. Click OK for both. It will take View a few minutes to load the file. Zoom out in the top view until you can see the entire terrain, then use Alt or Option and the mouse to orient the active camera view. Here's how it should look. I want to center the island better in the active camera view, so I'll click in the top view and move it to the left, then do a quick render to see how it looks. Select the terrain in the World browser and click on the Load Material button, then select the grass preset. Here's how that looks after a quick render. Now we need to add water. Click on the water icon, the water drop, on the left side to add a water plane. Water is added as an infinite plane, so you don't need to resize it. This is the tricky part. Click in the active camera window, the gizmo will appear. Important: when you click in the active camera view, the terrain will be selected, not the water. To select the water, click on it in the World browser. Slowly move the blue arrow upward until the water appears in the camera control view. Here I've moved it too far and put most of the island underwater. Now gradually move the water plane up or down until the land looks right. Use the XYZ controls in the object panel to nudge the water up or down in small amounts. I've speeded it up for this video. Now we'll do the final render of the image. We've already done the quick render in the active camera view. Now we'll create a large, high-resolution render suitable for printing. View has extensive rendering controls. The documentation goes into detail about this. We'll keep things simple for this exercise. Go to Render, Render Options. This window will appear. This is the Render Options control. Don't get overwhelmed. We'll only be using a few of these settings. In the left column, check the boxes for Superior and Render to Screen. In the top right section, set the aspect ratio to widescreen, the resolution width to 3000, and the units to 300 pixels. Click the Render button at the bottom. A new window will open. The render will take a minute or so. Here's what that looks like. At the bottom right of the window, there's a small button for Save Displayed Picture. Click that to save the file to your computer. Now you have a nice high-res image to work with. You can take it into Illustrator or Inkscape to add vector information, such as markers and callouts. Using View's World Map browser. View contains a built-in world map that lets you directly import terrain from the real world. This is a quick and easy way to get terrain into View. I recommend spending some time with this, even if you plan to import DEM files directly for most projects. Click and hold the Terrain button in the left toolbar and select the last icon. You'll see the world map. You can zoom and move around this map using the mouse scroll wheel and right button. The panel on the left lets you control the terrain import. This panel is important, so here's a summary. The Geographical View section lets you enter coordinates to go to a specific location. The Display settings lets you choose a dataset to import. The Satellite Imagery ones also give you the option of importing the texture, the image, along with the elevation data. Resolution of import lets you control the resolution of the imported terrain file. The 1024 setting produces results comparable to a 500-meter SRTM 15 plus DEM, while the 4096 setting creates results comparable to a 90-meter DEM. Area to import shows the coordinates of the selected area. Tile cache settings contains two important buttons: Import as procedural terrain and Import as height field terrain. These are the two types of terrain view can create. Here's a basic explanation of these. Height field terrains are simple elevation maps, with black for low and white for high elevations. These terrains are a fixed resolution. If you zoom in far enough, you might see resolution defects. Height field terrains place fewer demands on the computer and are ideal for background terrains or scenes that won't include close-ups. Most bird's-eye map scenes are well served by height field terrains. All of the examples in this video will be height field terrains. Procedural terrains are created by a fractal process. The geometry is recalculated to produce maximum detail whenever the camera view changes. Procedural terrains place more demands on the computer and are best suited for foreground terrains or close-ups. For details about this panel, see pages 240 to 250 in the documentation file. For our next project, we'll create a map of the chosen reservoir, site of a major Korean War battle. This time, we'll use View's world map. I'll go to Wikipedia to get the coordinates, then go to the FCC's converter site and convert these to decimal. In View, create a new document and click on the default atmosphere. Bring up the world map by selecting the last icon on the Terrain button. Click on the DD button, then enter the coordinates. Make sure you enter them in the correct fields. View will place a marker in the coordinates. Here I've zoomed into the area. The Sentinel option shows green vegetation. I don't want that, since the battle occurred in the winter. I'll select the altimetry and bathymetry option and set the height map resolution to 4096, then click Import as height field terrain. This box will appear. Click Let View change my scene. Once it's finished loading, you'll see the main interface. Here I've deselect the terrain. I'll tilt the terrain in the active camera view and do a quick render to see things better. Now I'll select the DM layer in the World browser and click on the Load Material button to bring up the material library. In the left column, click on Terrainscapes and select the Winter Ground Cover one. Here's how that looks. That looks good. I'll do the final render like before, then open the image in Photoshop. I'll get the Magic Wand tool and click in the area of the reservoir. I need to adjust the tolerance setting to select the right area. When it's selected, I'll fill the area with a dark blue color. And we're done. DEM resolution. The best resolution for a DEM depends on what you're doing. You might be tempted to use the highest resolution available, but that may not be the best decision. High-res DEM files, like the USGS 10-meter ones, are extremely detailed. That level of detail can be a distraction from what you're trying to convey. It also makes it harder to see text or other vector information that will be placed over the DEM. Here's a scene in Wyoming using several different resolutions. DEM versus world map. Whether to use a DEM or the view world map largely depends on the resolution you need for the project. Here are two examples of the same area, part of Grand Teton National Park, at two different resolutions, using the view world map. Both are height field terrains. When I tried importing this area as a procedural terrain, I got a warning about the number of polygons that would be needed, over 6 million. I tried to import it anyway, but my computer froze, and it has 72 gigabytes of memory. Procedural terrains are only an option for small areas. If you're capturing a large area, you don't need that level of zoomed-in detail anyway. Keep the final goal of your project in mind. If you're creating a 3D image to show the effect of terrain on a battle, for example, too much detail can be a distraction. Some of the world map datasets, the ones with satellite images, will already show shadows. If you want to control the sun angle in your image, this can be a problem. You'll get the best results by matching the sun position to the image. Also, the texture maps from imagery like Sentinel are not always good quality. The resolution can be low. Overlays can add a lot of realism to a scene, but they're not always a good idea. Areas with a lot of vegetation, such as forest or jungle, can look too dark to show the terrain very well, and this makes it hard to place markers or other features on the image. Here's the chosen reservoir image using the Sentinel-2 overlay. It might actually look like that, but as a map it's not very useful as an explanatory tool. Many scenes will work better with either a material applied to the terrain or just a solid color. Here's the same scene with the gray mountain material. Much better. Trading realism for clarity is usually a good choice. Also, if you're depicting an actual event, keep in mind what time of year it occurred and choose the material accordingly. Monte Casino map. Creating 3D maps of areas outside the United States usually requires using data from a source like OpenTopography. This will not be as detailed as USGS data, but that's usually not a problem. Keep in mind that maps are deliberate simplifications of reality. Even though View lets you create scenes that look like a photograph, making it too realistic works against its purpose as an explanatory tool. For this exercise, we'll create an image of Monte Casino, the scene of a World War II battle. First, I need to find the exact location. So I'll go to Wikipedia and search for Battle of Monte Casino. Since OpenTopography uses decimal coordinates, I'll convert these using the FCC's conversion website. I'll go to OpenTopography's map and click on the Zoom to Location icon, then enter these numbers into the bottom fields. Remember that the longitude goes first. Here's what I get. I'll refine the area a bit. Now I'll scroll to the bottom and select the Copernicus 30-meter file. Once it's downloaded, I'll unzip it and import it into View. I'll do a quick render in the active camera view to get a better look. Looks good so far. Now we'll add a material. For this one, I want to focus on the elevation, not the actual topography, so I won't use a natural material. Instead, I'll give the terrain a single color. I'll select the terrain in the World browser and click on the Load Material button. In the library, I'll click on Basic and select the flat white material. Here's how that looks after a quick render. I want a light gray color, so I'll double-click on the material in the Object Aspect window to open the material editor. To change the color, I'll double-click in the Overall Color window to get a color picker. I'll select a light gray. Click OK twice to return to the main view. Click the Quick Render button. The yellow cast is from the sun. Now I'll change the camera position. I want the view to simulate what soldiers on the ground would see, so I'll zoom in and tilt the active camera view until I get a view I like. I'll call this one done. Render it using the same steps as before. In this case, I wanted a deliberately simplified image that focuses on how the terrain affected the battle plans. Small area maps. Some map subjects are very small areas, so small that using an actual DEM isn't practical or even possible. Here are two examples. If you have access to the USGS 1-meter data, you might be in luck, but I'll assume you don't have that access. I don't. In cases like this, the best option is to create an elevation file yourself in Photoshop or GIMP. This is pretty easy to do. View can import grayscale files as height maps. These are easy to make in Photoshop or GIMP. In Photoshop or GIMP, create a new blank document. This can be a square or a rectangle. I'll create a square that's 2048 by 2048 pixels. The resolution doesn't matter. Important, select 16-bit from the pull-down menu. Creating the file as 16-bit is essential. Using a normal, 8-bit setting will produce stair-stepped elevations in your terrain, and the file has to be created as a 16-bit. You can't create it as 8-bit and then change the setting afterward. Fill the area with a medium gray, 40 to 50%. View will read the file as a height map. White is high, black is low. By using a medium gray, you have the option to make the terrain both higher and lower, whereas if you used a white shape, you could only lower the terrain. Make sure the foreground color is set to black, then click on the brush tool and set the size to 1000 and hardness to 0. In the top toolbar, set the opacity to about 10 to 15%. Paint over areas that should be lower. Remember, white is high and black is low. Painting over an area more than once lightens or darkens the image accordingly. A little can go a long way with this technique, so you'll have to experiment. Save the file as a TIFF with no compression. Go to View and import the file. You can import it as a height field or procedural terrain. I'll use height field since I don't need a lot of detail. Now I'll position the terrain the way I want it using the active camera view in the camera controls. That looks good, so I'll do a quick render. I'll select the terrain and click on the Load Material button, then add a grass material. Here's how it looks after a quick render. Our terrain looks good so far, but it's pretty bare. Next, we'll add some trees. Here's a map of Borodino. The trees are important because Russian forces use them for concealment. View has several ways of adding trees and other vegetation. You can add a single tree or bush, but that's not very practical. Luckily, View has a powerful system that lets us add a bunch of things at one time by painting vegetation onto our terrain. We'll continue with our terrain from the previous step. Click on the terrain to select it, then double-click on the Material window in the Object Aspect panel to open the Material Editor. Right now, you can see that one material, grass, has been applied to the terrain. First, I'll add a new layer and rename it Trees. Click on the menu that says Simple Material and select Ecosystem, Particles. And you'll see this window. First, we need to add something. Click on the Add Item button. A menu will appear. Select Add Plant. The plant library will appear. Click Trees in the left column. Click on a tree that you like. I'll pick the white oak. Double-click on the tree to add it. This returns you to the Material Editor, where you'll see your tree. It's a good idea to add more than one type of tree to make your scene more realistic. I'll repeat these steps to add 2 more kinds of trees. That looks good. The tabs let you control the appearance of the trees. See the documentation for more about these, or just experiment to see what happens. We'll leave everything at the defaults for now. At this point, if you click the Populate button, View will cover the terrain with trees, which is probably not what you want. You can see this in the camera control panel. We'll paint the trees on instead. Click Clear to delete the trees, then click on the Paint tab and a new window will open. Click OK on the Material Editor window to close it. The controls on the Eco Painter window let you control how the trees will be placed onto the terrain. Adjust these controls as you wish. I'll change the brush radius and leave the rest alone. I prefer to use the top view when doing this, so I'll move the Eco Painter window out of the way. I'll hold down the mouse button to paint trees onto the terrain. Close the Eco Painter window when you're done. Now I'll do a quick render. And there are my trees, complete with shadows. The shadows will be determined by the atmosphere you choose. I'll zoom in and change the camera angle to demonstrate this. Here's the same scene using the Noon Sky preset. You can see that the shadows are directly under the trees, as you'd expect. View gives you a lot of control over every aspect of your scene. For this scene, I want to make the trees smaller and add some more, so I'll go back into the material editor. One issue that I found with View is that once you close the material editor, you can't change the trees. You need to delete them and start over. I'll do that by clicking the Clear tab. Using this method, you can create maps like this one of the Battle of Agincourt. To get this effect, I'll go back to the material editor and delete the trees from my terrain by clicking Clear. Then click on the Scaling and Orientation tab and adjust the overall scaling slider to a value of 0.7. Finally, I'll click Paint and paint the trees where I want them. Here's a final rendering. An image like this could be created in Photoshop, but one of the advantages to using View for scenes like this is you have the option of creating multiple perspectives of the event or battle, like these. Painting trees onto our terrain is pretty easy, but sometimes you'd like to have more precise control. Using View's mask capability lets us position trees and other things exactly where we want them. Here's how this works. We'll create an image in Photoshop or GIMP and paint areas that we want to be higher or lower, just like we did earlier. Then we'll add layers for other things, like trees, and paint where we want these to appear. View will then use these layers as masks to position things on the scene, just where we want them. We'll start with the terrain we used in the painting method. Open it in Photoshop or GIMP. It should still be a 16-bit file. Get the paintbrush tool and set it to about 500 pixels with 0 hardness, with opacity set at 15%. Select black as the color and paint a line through the scene like this. This will be a river valley. Go to File, Save As, give it a name, and save the file as an uncompressed TIFF. I'm going to add 3 things to this scene: trees, a sandy area, and a river. In Photoshop, I'll add new layers for these things, plus a layer called black just above the background layer. These layers will become masks for View to use when applying materials to our scene. First, we'll create the tree mask. Select that layer and get the brush tool. Set the size to about 300 and the hardness to 25%. Set the opacity to 100% and the color to white. Paint wherever you want trees, roughly like this. Next, we'll add the sand area. Turn the tree layer off and select the sand layer. Using the same settings as we did for the trees, paint an area in the upper right corner, like this. Now we get to the river layer. The river should run along the valley we created earlier. Turn off the sand layer and select the river layer. This time, set the brush tool to a size of about 100 and a hardness of 80%, then paint your river like this. You can make it wider in some areas if you want. Finally, select the black layer and fill it with black. Now that our layers are ready, we need to save them to use them in View. First, duplicate the file. This is very important. Using the duplicate file, turn on the trees layer. Only the trees and black layers should be visible, like this. Flatten the file and save it as an uncompressed TIFF. The mask files can be 8-bit or 16-bit. It doesn't make any difference. Our tree mask is ready. Now duplicate the original file again and repeat these steps for the sand and river layers. Here's what they should look like. Now we're ready to go to View. Create a new document and import the new terrain file. You can choose height field or procedural. I chose height field. Select the terrain and click the Load Material button, then choose Grass. Now do a quick render. I think the terrain is a bit too strong, so I'll click in the front or side view, then click in the top middle control point and move it down. That looks better. Now we're ready to add our other stuff. I'm going to add the trees last, since they will partially cover up the terrain and make it harder to see what I'm doing. We'll add the sand first. To do that, open the material editor by clicking on the button in the Object Aspect panel, or double-click on the little preview. When the material editor opens, make sure it's the Advanced editor. Click Add Layer to add a new material layer, then pull down the mapping menu and select Object, Parametric. This will align the new layer with the existing terrain. This is very important. I also changed the name of the layer to Sand. Now we have some settings to change. First, click on the Color tab and change mode to Natural Grain. Then click on the two color boxes and select Sand-like colors. Also check the Use Color To box. This will mix the two colors together. Next, click on the Alpha tab and select Mapped Picture. This will bring up a dialog box. Click on the folder icon and navigate to your saved TIFF files from earlier. Open the sand file. Back in the material editor, you should see this. If you look at the camera control view, it will look like this. The sand and grass areas are backwards. To fix this, click on Invert next to the mask preview window. Here's a quick render. Looks good so far. Next, we'll add the river. Double-click on the material preview to open the material editor, then add a new layer. Pull down the mapping menu at the top and select Object, Parametric. Click the Color tab, select Constant, and set the color to a darkish blue. Click the Alpha tab and select Mapped Picture. Then select the river mask file. You'll probably need to click the Invert button. Click OK and the river's done. Here's a quick render. And finally, the trees. These are a bit tricky. Adding the trees means adding three-dimensional objects, not just changing the color of the terrain, like the sand and river. This involves a few more steps, some of which I don't fully understand, but here goes. Here's the method that works for me. Double-click on the material preview to open the material editor, then add a new layer. Make sure it's set to Object Parametric. Then change the top menu from Simple to Ecosystem, Particles. Click the General tab, then click Add Item, then Add Plant. This brings up the plant library. Click on Trees in the left column. To add a tree, double-click on it. Like before, it's a good idea to use more than one type of tree, so repeat this process and add two more. This will put you back in the material editor. Note, you can change the proportional mix of the trees by changing the values in the Presence column. They should total 100. Click on the Density tab and check the Variable Density box, then right-click on the Preview window and select Edit Function. This will open the function editor. Don't panic. We'll be doing something simple here. In the left column, click on Texture Map, then double-click on Projected Texture Map in the next column. This will add a box to the main area. Zoom into the new box using the mouse wheel. You'll see three options below the box. Click on the little circle next to Grayscale Output and drag a connecting line to the Density box. Click on the Load button below the black square. A dialog box will appear. Click on the folder icon. Navigate to the Trees mask and click Open, or double-click on it. This returns you to the editor, where you will see the mask in the square now. Click on the Advanced Material Editor tab at the top. Enter 10 in the X and Y function boxes under Function Scale. Finally, click the Populate tab, and you should see trees in the camera control window. If your trees are reversed, go back to the Function Editor and click the Invert button next to the mask preview. You can change the size and appearance of the trees. You can adjust the settings in the Density tab to change the overall density and clumping of the trees. Click on the Scaling and Orientation tab. The overall scaling slider controls the size of the trees. Here's what a setting of 4 looks like. I'll use a setting of 2. Here's a quick render. We're almost done. Small area scenes like this are deliberately showing only a small slice of the world. Instead of hiding that fact, show it off. First, I'll rotate and tilt the scene to bring one of the corners toward the camera. Now I need to get rid of the ground layer. One way to do this is to simply delete the ground layer from the world browser. Here's what that does. The problem with this method is that it can be hard to delete the tan layer in Photoshop, since that's probably not the color you want there. Here I selected the ground layer and set the material to flat white. That's better. There's a bit of color at the top, but that's easy to remove in Photoshop or GIMP. Next, I'll set the ground layer to black. That's also a nice look, but we still have the fade at the top. I'll go with the white one for now. The other issue is the sides of the block. I'd like them to be solid colors, so I'll do a final render first, then I'll open it in Photoshop. There's a slight tan color to the background. There are several ways to change this to white. I'll click on it with the magic wand tool and delete it. Now I'm ready to color the sides of the block. I'll add a new layer for the front side. First, I need to select the front section of the block. There are several ways to do this. I recommend trying the easy way first, the magic wand tool. I'll set the tolerance at 25 and click. It doesn't work very well on either side, so I'll have to do it the hard way. I'll use the pen tool to draw the shapes. This can be tricky. You'll probably have to add some curve control points. Now that the front face is outlined, I'll bring up the path panel and click on the flyout menu, then select Make Selection. This turns the path into an active selection. I'll fill it with a dark green color. Since the color is on its own layer, it's easy to change later if you want. Now for the other side. I'll create a new layer for it first, and also pick a color for this side. I'll use the pen tool to trace the outline of the side face, then repeat the same steps to fill it with a lighter green. And we're done. Now we can take this image into Illustrator or Inkscape to add the vector information. There are some excellent view tutorials on YouTube. The best are from Vladimir Chopin, who also has a book you can get on Amazon. It's for an earlier version, but most of the information is still relevant and very helpful. It's better than Vue's documentation. This should get you started with Vue. As you can see, it goes far beyond QGIS's 3D capability. Plus, it's just really cool. Check out my designer's guide to creating great maps at the mapguide.net/guide and download 2 free chapters. That's all for now. See you next time.